proves them congruent. One is called SSS, meaning all the three sides of this triangle and this triangle are same. Meaning this is 1 matching. This is 2 matching. This is 3 matching. If they are same, then the triangles are congruent. And I have proved that in the previous classes. If we need to prove it again, I will certainly do it. Not today, some other day. Based on public demand. So if you guys want me to do that, I'll do it. Now, second theorem says ASA, meaning two angles and the side between them. So if you have two triangles where this angle is matching with this angle is matching with this angle, and the side between them are also of same length, then they are congruent, meaning then everything else will match. You don't really have to match each and every property. This is another theorem which says, first theorem says if you have matching sides, then you can assume that they are congruent, and then the angles will match, the area will be the same. If there are two triangles where the two angles are having same value and the side between them has the same length, they will be congruent, meaning the other angle will match, other sides will match. Third theorem says SAS, meaning the two sides and the angle between them. Let's say if these two sides and the angle between them, meaning this side and this side matching, this side and this side matching, and the angle between them matching, then they will be congruent. And you don't have to blindly kind of acknowledge or accept it. There are ways to prove it, which I have done in the previous classes. We can do it later, whenever you guys want me to. Okay. And the fourth one is called RHS, which is this theorem of congruence is for right angle triangles, meaning if there are two right angle triangles where R stands for right angle triangle, where the hypotenuse, meaning this one and this one matches, and one of the side, be it this one or this one, this one or this one, if the hypotenuse and one of the side matches, they are congruent. And this theorem is predominantly only for right angle triangle. Not predominantly, this is only for right angle triangles, and the other three are for any and every type of triangles. So I am just doing a recap of what the theorem of congruence is, and I'm sure you all would be knowing about it. If you don't, just go through it. In the future classes, I will also prove why these theorems are to be believed. Okay, if I have not done that for any of you in the previous classes. Okay, so if anybody gets if anybody feels that okay, I don't know how these are to be believed, for now you memorize it, and in one of the classes I will explain that also. I'll prove these theorems as well. Okay. So these are just the theorem of congruence. I have just tried to recollect here because we'll probably need to reuse them for proving some of the circle theorems as well. Was it okay, or was it a roller coaster?
I understand it, sir.
Saida?
I understand it.
You understand it. Anybody who did not? I mean, I did not explain anything. I just told what are these theorems. So basically, if you have two triangles, what are the ways you can find out if they are congruent or not? And if I ever say congruent, that means exact copy. If you are printing two pages in your printer, they are congruent. They are the same size. You don't have different size paper, right? So congruence means exactly the same. No difference at all. Yeah. All right. So let's move on. So there are total 7 theorems with the circles, and we will try going through them one by one. And we will, whenever needed, we'll use the knowledge of theorem of congruence to prove it also. So whenever I say theorem, right? Theorem means you have to prove it. Otherwise, it ends up just being a formula or a theory that you have to remember, and that is not correct. I don't believe in that, and I don't want any of you to believe in memorizing when it comes to math. Alright, the first theorem says alternate segment theorem, meaning this is, let's say this is, drawing a triangle and then okay. So alternate angle theorem. In definition it says, let me read the definition for you because I don't memorize them. Angle that lies between a tangent and a chord is equal to the angle subtended on the same chord in the alternate segment. So now the angle that lies between the segment and a chord. So let's okay. Now we have to understand what is a chord. Can somebody tell me what is a chord? I did not say that. If anybody knows what is a chord here, you can explain me. Explain to me and to everybody. Yeah.
The chord is the line that's next to the circle over there. I don't know how to explain it, but I know how to identify it.
Okay. Okay. Yeah, Ritika. Go ahead.
A chord would be a line segment that connects two parts of the circumference.
Okay.
So a radius would be.
Let's say
a round
ABC.
circle.
Okay, ABC, and this is a line. Let's say D. Okay. Now you tell me what is a chord here.
AB is the chord.
A and B
is
is
the
the-
chord. CA is the
Yeah.
chord.
Right. Yeah, here.
It is also a line that does not pass from the center of the circle.
Right. Correct. So basically, so far, whatever we were doing, right? When we talked about the arc and segment, we were always talking about the center, the radius, two radius doing on the magic, with the perimeter. That's what we were dealing with. Now comes a third situation. See, essentially, this we called as a center angle. This one we called as a arc, and this one we called as a sector area. Now, these 2 points where the radius are meeting, if you join them, that is called chord. Okay. So the first theorem says. So I think that was the only thing that I missed to explain you guys when I talk about the properties. The first theorem says the angle that lies between a tangent and a chord is equal to the angle subtended by the same chord in the alternate segment. So if this is let's say let's say A and C is a chord, is one of the chords. Okay. So basically, as Ritika mentioned, right, AB is a chord, BC is a chord, AC is a chord, right? You can always join this with the center, and this will be called arc, and this whole area will be called segment. So we are not doing that. Right now we are not dealing with the center. We just picked the 3 points on the circle, and we join them, which looks like a triangle here. The first theorem says the angle that lies between tangent and a chord. This is the tangent, right? So let's say if you are picking up this one. Let's say we pick BC as a chord, L is the chord. BC is the chord, and this is this line D is tangent. It says the angle that lies between the tangent and the chord. So this is the chord, and this is the tangent. This one is tangent, meaning this is drawing. This is just touching the circle and crossing this one. Says essentially, if you look at it this way, this line and this line will be parallel. But anyways, let's not worry about that. It says this angle and this angle will be the same. The angle that lies between a tangent and a chord, is same as equal to the angle subtended by the same chord on the alternate segment. So this is the other segment. So this angle and this angle are same. This is the first theorem of circle. So look at this. So basically you have a circle where you have picked up 3 points and you have joined them, and you have drawn a tangent here. Essentially, if you look at this line, this tangent will be parallel to this one. That is how it is. Because when you draw tangent, this has to cross this point and has to be parallel to this one. Am I going in the wrong direction? No? Yes? No. Okay. So the first theorem says if you have 3 points on a circle on the perimeter, if you join them, they are the 3 chords you have, and it says when you draw a tangent crossing one of the points, the angle made by the tangent on this chord will be equal to the angle subtended by this on the other side of the on this segment. So see, look at this. This is these two. Let me just read the definition, otherwise alternate segment. Okay, now this is, that's why I was wondering. Yeah, the theorem says the angle that is made by this chord is equal to the angle made by the alternate segment. This is the first theorem. Now, can somebody tell me how this angle will be equal to this angle? This is the first term. It says if you have 3 points on a perimeter of a circle, the angle made by this between this tangent and this chord will be equal to the alternate angle made by this segment. So basically, if these 2 points that you have and you are joining it with the third line, this angle and this angle will be the same. Can somebody tell me why that would be the case? Now look at this. This tangent, this line that is tangent here is parallel to this guy. Okay. So when you have 2 parallel lines, this angle. Yep. Yeah, Ishwari.
Is it because they're alternate interior angles?
Alternate interior angles. Okay, so
As if chord AB is parallel to line D's C.
right.
Line D, it's their interior, alternate
Right.
interior angles. Right?
So yeah. No, again, see, the question is this. This one is equal to this one. If this one and this one are equal, that is understandable. These are alternate interior angles, right? For 2 parallel lines. The question here is this and this are same. How is that possible? Ritika, Dev, Chris, anybody? Nobody? Okay. Let me okay. So the simple thing is this, okay? When you're talking about these 3 chords, right? This angle and this angle are same. And apparently what you will realize, what you will find is this, okay, let's do one thing. We'll come back to this one. This is probably the toughest of the 3 of the 7. This one we'll come back to this one because we have to prove other few theorems that will make it easy here. Okay, let's park this one for a little bit. First theorem will come back later. Okay, let me pick up another one which will help us solve this one a little later. Okay, another theorem says if you have a circle, okay, this one we can relate, and pick up any point here. Okay, so this was your center angle. Okay, so if you look at any circle, if you look at these 2 radius making angle, this is making one angle here and one angle here. Correct? There are 2 angles that it makes. This is a smaller arc, this is a larger arc. Correct? Now it says if you have taken, let's say this is A, O and B. This is making two, one angle is this one, other angle is this one. Correct? So I will put point here C and I will put a point D here. So if I say angle OACB, meaning this part, the smaller one. If I say angle AOBD, AOBD, so that way I am talking about the bigger angle. What this theorem says that if I have an arc, if I have two radius meeting here, the angle that it makes on this side, look at the other side, pick up any point here or here, any point. This angle will be double of this angle. So again, let me keep it. I'm doing it online. I'm doing it undo. Here I don't have the option to undo. So if this angle is, let's say, 120 degree, I pick up any point here. I just join this same 2 points, joining with any point. I can pick this point, I can pick this point, I can pick this point. This angle will be half of this angle. So if I have an arc making angle, if I look at the other side of the arc and pick any point on the perimeter, join that with that one, that angle will be, this angle, let's say theta, will be equal to half of this angle. Now the question is how? Were you guys knowing this theorem, or I'm kind of bringing it from nowhere? Okay. Let me try proving it first. So this is a circle. And this is the center. Let's say AB. And this is my center O. This is making 120, whatever angle. 120 degree, let's say. Okay. This theorem says you pick any point anywhere on this one, and that you join that point. So this makes an angle. This angle is half of this angle. Now you will say why? Let's try proving it. What will I do? I will join this point. Let's say this is C. Join this point and break this into two parts. So this becomes two triangles now. I have triangle AOC and triangle BOC. And triangle BOC. Are you guys with me, or it's kind of getting boring? I don't see any participation, so I'm getting a little worried actually.
It's making sense, sir.
Okay. Alright, so this theorem says that the angle made by this arc or this segment is double of any angle made on the other side of the segment. Meaning you can pick any point, okay? So I just pick this point and I join that. And we are trying to find out if this angle is half of this angle or not, okay? So let's try proving that. Here what did I do? I joined this point and this point. So that breaks it into two triangles. Now if you look at this triangle alone, meaning if you look at triangle AOC, what do you see here? This angle, this is one angle, but this angle and this angle are same, meaning angle OAC is equal to angle OBC. angles are same? See, look at this triangle. This side and this side are same length, right? Both are radius, correct? Yeah. So that means it's an isosceles triangle. If it's an isosceles triangle, that means the angle, this angle and this angle will be same. The angle applying to the equal side will be same. So this angle and this angle are same. Now tell me, this angle and this angle. Now, other thing that you need to know, angle OCA plus angle OAC plus angle, this middle one, AOC equals 180 degree, correct? And if you just draw this line straight, this part of the angle is, this angle plus this angle is also 180 degree, correct? So here that means this part of the angle is this plus this, agree? So here look at this straight angle, this angle plus this angle makes 180 degree. All the three angles of a triangle makes 180 degree, and these two angles are same. So meaning sum of these two angles is equal to this angle, correct?
Yes, sir.
Now sum of these two angles is equal to this angle, no doubt about it. Now these two angles are same. So 2 times angle OAC equals this angle. Let's say here it is K. So that is angle AOK. Yeah, agree? So see, look at this. We found that this is an isosceles triangle. That means this angle and this angle are same because these two are radius. So these two angles are same. So 2 times of this is equal to this because this and this makes 180 and these three make 180. So this plus this, which is 2 times of one of the angle, is equal to this. Same way, if you look at this triangle, you will see that this angle is 2 times of this angle or this angle, any which way. So this angle is, which is this plus this, is 2 times of this plus 2 times of this. That, so if I write that in simpler terms, so let me, if I am talking about triangle AOC, what we found was this is an isosceles triangle. That means this, because this side and this side are same, so this angle and this angle will be same. So from this we found that 2 times of this angle or this angle, both are same in which way. So I will say 2 times of angle ACO equal to this angle, correct? Which is angle AOK. Now same way, if you look at this triangle, this is also an isosceles triangle where these two sides are same. That means this angle and this angle will be same, and again this angle plus this angle will be equal to this angle. So that means 2 times of angle BCO will be equal to this angle, that is angle BOK. And if you add these two, angle AOK plus angle BOK, that makes angle this one. Angle, this makes angle this one, AOB. Now, and then when you are adding these two and getting this one, when you add these two, what do you get? 2 times of angle ACO and angle BCO, that makes it angle ACB. This plus this makes angle ACB equal to angle. So from this we saw that this angle is 2 times this angle. Now I know I might have created a lot of confusion, but let me repeat it. What we were trying to prove, I have an arc, this was AKB, which is making certain angle on the center. This is my center angle. What this theorem says is, if you pick any point on the other side of the arc, if you are picking up this arc, pick any point on this side. and it says if you join this with this, the angle that makes here, that is half, this angle is half of this angle. So if this arc is making certain angle on the center, that angle is 2 times the angle made by this arc on the other side of the perimeter. Anywhere on the perimeter, only on the perimeter. And that is what we saw here when we just picked the point C and then join that. And we saw that this, you look at this triangle, this is isosceles triangle, this angle same, means sum of these two angles is equal to 2 of one of the angles is equal to this one, because it's a straight line, straight angle. So this plus this is 180, and this plus these two are 180, and these two are same. So 2 times of this is equal to this one. Same way we found 2 times of this angle or this angle is equal to this one. So that helps us prove this theorem as any angle made on the other side of the arc on the perimeter is half of the angle made on the center by the arc. Okay. So was this clear to you guys or still confused?
It was clear to me.
Okay. How about Dhanushri, Aryan, Heer, Ishwari?
It was clear.
Clear? Okay.
Yes, clear.
Okay. So I'm assuming, I was thinking that I would be able to cover 7 theorems, but again, understanding the things, understanding the concept takes a little bit of time. So that's why we took a little longer and we spent some time on this one. So what we'll do is we'll try covering the remaining 6 theorems. We'll try going a little fast so that we can cover the circle theorem at least by tomorrow. Yeah, the other 7 theorems. And we'll try going fast. We have to do a recap of the theorem of congruence, because that we will be using that as well. So we'll probably stop